Okay, so today's notes are going to be about multiplying a monomial by a polynomial or vice versa, a polynomial by a monomial. So first, before we get started, just real quick that you should definitely know that mono means one. So a monomial is just one term. So for example, 3 or 3x, those are monomials. A polynomial, so the word or the root of polynomial, poly, means multi. So a polynomial is anything that has multiple pieces. So for example, 3 plus 3x would be a binomial because it has two pieces. If I added on a 5y, that would be a trinomial, say plus or minus something, so minus 1. After three pieces, after a trinomial, we then just start calling them a polynomial. So again, what we're going to be doing today is multiplying one piece, so like 3 or 3x, times a polynomial, so a multi-piece expression. So before we do that, it is really important that you know the difference between x plus x and x times x. So we have been adding variables for the last few weeks. So this is like 1x plus 1x. So hopefully you remember we just add the 1 plus 1 and we would get 2, and then we keep the x term with that. So this would just be 2x. Sorry, my pen's not working very well today. Let me try that again. So again, a 1x plus a 1x, we would just add the 1 and 1, we get 2, we keep the x. Okay, very different than x times x. So x times x is just like anything times itself. So for example, in middle school, you should have learned that 2 times 2 is the same thing as 4, right? You should know that. However, you also should know that you can write that as 2 squared, right? Anything times itself we can just say is squared. So x times x similarly can just be rewritten as x squared. So that's a little 2 there. So x squared. So x plus x is 2x. X times x is x squared. All right, so looking at the examples, we're just going to simplify. So this is going to look very similar to just distribution, and it is just distribution. The difference is going to be when we're actually distributing an x term. So starting with number 1, we're just distributing negative 3. So we do negative 3 times x, which is negative 3x. And then negative 3 times negative 7 is going to be positive 21. We can't solve this because we don't have an equal sign. That negative 3x and positive 21 are not like terms. So at this point, we are done. We are done simplifying the expression. All right, so looking at number 2, very similar. We're just distributing a 4. So we do 4 times b squared is just 4b squared. 4 times positive 2b is just positive 8b. Again, I multiply the coefficient times 4. And then same thing, the last term, 4 times negative 3. 4 times negative 3 is minus 12. So just like on the last one, we have a b squared term, a b term, and a constant term. So we're done. We cannot combine those. They're not like terms. We don't have an equation because we don't have an equal sign. So at this point, we're done. All right, so looking at number 3, very similar. A lot of students see the squared and they think that they really need to do something with it. You actually don't. So we're just doing negative 5 times negative 2. So we multiply the negative 5 times the coefficient. That would give us 10. And then we leave that w squared. We don't actually do anything with that squared. So no math really required there. Negative 5 times negative 6w. Again, we just multiply the negative 5 times negative 6 would give you positive 30w. And then the last term, we have a negative 5 times a positive 5 would give us negative 25. Again, we have a w squared term, a w term, and a constant term. Those are not alike. We can't combine those, and we don't have an equal sign, so we don't have an equation to solve, so we are done. So number 4 is similar, but this time we're distributing a k also. So we're distributing a 3 and a k. So really important. So 3k times k. Again, we just do 3 times 1 here is 3. And then k times k is very similar to x times x. So x times x is x squared. So k times k is just k squared. So that's going to be 3k squared. And then we do 3k times 2, which is similar to what we've been doing this whole time. So we multiply 3 and 2, we get plus 6. Keep the k. So again, a k squared term and a k term are not like terms. You cannot combine those. So again, at this point, we are done. There's no equal sign, no like terms to combine. We're done. All right, so looking at number 5, same thing. We're distributing a 4 and an 8. So we're going to do 4 times 3/4. So if you use your calculator, or maybe you don't need to use your calculator, 4 times 3/4. This 4 and 4 actually end up canceling, so we're just left with 3. So that's going to be 3. H times h is h squared, so 3h squared. And then 4h times positive 2 is plus 8h. H squared and h are not like terms. You cannot put those together, so we're done. Right, number 6. So number 6 is similar, but now it's in terms of a word problem. So it says, Jacob drew a floor plan for his living room as shown below. What is the area of Jacob's living room? So hopefully you remember that to find area of a rectangle, we do area equals length times width. So we're going to multiply the length of 5x times the width of 2x minus 3. So if I wrote that, let me scoot down here. If I wrote that out, it would look like this. I would do 5x times 2x minus 3. So basically all I'm going to do is distribute the 5x to the 2x. So very similar to what we've been doing. 5 times 2 is 10. And then a new piece is x times x is x squared. And then we do 5x times negative 3. So 5 times negative 3 is negative 15. And we bring that x with it. So the area of Jacob's living room would be 10x squared minus 15x, and I would add in square units. So square units. Okay. All right. Number 7 is very similar, but it's just getting a little bit more complicated now. So a few more steps, but still the same process. So we're going to do 3x times 4/3 x. So again, 3 times 4/3. If you use your calculator, you'll see this. If you don't have a calculator, you should just recognize that those 3's will cancel out. We're going to be left with 4. And then x times x, again, is x squared. Then we do 3x times positive 3 is plus 9x. All right, and then we stop distributing because that parentheses right there ends, and then we pick it up immediately. So then we do 5 times 7/5. So again, 5 times 7/5. You should notice those 5's will just cancel, so we get plus 7x. Then we do 5 times negative 4 is minus 20. So this one is just a tiny bit different because we have lots of pieces. So this is a polynomial, it has 4 pieces. So we have a 4x squared. I don't have any other x squared terms, so I'm just going to bring down 4x squared. But then I have a positive 9x and a positive 7x. So I'm actually going to put those together. Those are like terms. So 9 plus 7, you should know, is plus 16x. And then I have just a constant negative 20 all by itself down here, so I'm going to leave that as negative 20 on the end. So our answer, or simplified expression, is just 4x squared plus 16x minus 20. All right, so looking at number 8, same process. We have 2 sets of parentheses, so we're going to distribute twice. So we're going to do 2x times 1/2 x. Basically, that's like 2 times 1/2, or half of 2. So half of 2 is just 1, right? Again, if you multiply this out and you did it like this, those 2's just cancel and you're left with 1. X times x is x squared. So you can write 1x squared. You could also write that as just x squared. Those are the same thing. 2x times negative 3 is minus 6x. All right, we stop distributing because our parentheses ends, but then we immediately pick up distributing the negative 4. So negative 4 times 6 is minus 24. Negative 4 times negative 2x is plus 8x. So now, just like last week, we're looking at what can we combine. So we have an x squared here by itself right there. Nothing else to combine, so we're just going to leave that. But then we have a negative 6x and a positive 8x. We can put those together. So negative 6 plus 8 is plus 2x. And then we have this constant of negative 24 by itself, so we're just going to leave that as minus 24. So our final simplified expression would be x squared plus 2x minus 24. All right, number 9. Same thing, but there is one small difference here, and that is that we're not distributing this 10 in the front, right? That 10 is right there. We're going to leave that. What we are distributing is a negative. So hopefully you remember that when we distribute a negative, just everything changes to its opposite. So a negative distributed to an x becomes its opposite, which is going to be negative x. And a negative distributed to a positive 7 makes that become its opposite. So the opposite of 7 is just negative 7. And then we stop distributing because our parentheses ends, and then we immediately pick up distributing an x. So x times 2x, that's like 1 times 2 is just plus 2, but then x times x is x squared. And then 1x times negative 4, so 1 times negative 4 is negative 4, and we keep that x with it. And now we're going to combine like terms. So maybe you remember we always start with the highest degree. So I'm going to start with a 2x squared. I don't have any other x squared, so I'm just going to bring that down. That's going to be my first term, 2x squared. The next terms are going to be my x's. So negative x and negative 4x are going to go together. So that's like negative 1 minus 4. So negative 1 minus 4 more would be negative 5x. And then the last thing is going to be my constants. I have 10 minus 7. So 10 minus 7 is just positive 3. So my final simplified answer for that one is 2x squared minus 5x plus 3. All right, number 10. Very similar. We have a 12 in the front that we are not distributing, so I'm just going to bring that 12 down. What we are distributing is a negative 3. So negative 3 times x, hopefully you know, is negative 3x. Negative 3 times negative 2 is going to be positive 6. We stop distributing because our parentheses ends, and then we immediately pick up distributing again. So we do 6x times negative 2/6x. It's hard to say. So again, I'm going to write that out down here. 6 times negative 2/6. These 6's just end up canceling, and we're just left with negative 2. So minus 2, and then the x times the x here is x squared. And then we do negative 6 times, actually that's not negative 6, that's a positive 6 times a negative 3, that's actually positive 6x times negative 3, is going to be negative 18x. My last step, just like on solving equations and simplifying expressions from before that, combine like terms. So start with the highest degree. So we have an x squared right there, no other x squared, so we're just going to leave that. So that's going to be negative 2x squared in the front. Our next terms are going to be just the x's. So we have a negative 3x and a negative 18x. So we do exactly that math. We're not moving across an equal sign. We don't even have an equal sign. So we just do that. Negative 3 minus 18. So hopefully you remember you add those and keep the negative. So it's going to be negative 21x. And then the last pieces are going to be our constants. So we have a positive 12 and a positive 6 that are just constants, so those go at the end. And we just do, again, exactly that math. So 12 plus 6 is positive 18. So our final simplified expression there is negative 2x squared minus 21x plus 18. And that is all of those examples.